Okay, hi everyone. Thank you for the nice introduction and thank you for inviting me to this panel. I'm very happy to be here and excited to be here. Oh. Okay, as the other speaker said during this building industry, we have to face some challenges, and so we have to choose, as in the movie Matrix, digitization and to decarbonize the industry or let it slide. It is up to us, but in my opinion, timber is and must be part of the solution. Timber is a kind of a new material for the building industry, but we have to find new ways to use to make timber the most cost-effective solution to go for. And the reason is very simple. Is the world asking for this? So we need to go for more sustainable materials. We need to store CO2 or to reduce the CO2 emission instead of emitting CO2 as other materials does. I'm not saying to get rid of steel and concrete. I'm more saying to use the materials in a wiser way. The industry, the timber industry is already there. And this diagram shows how the CLT production, the global CLT production, is skyrocketing all over the world. We expect to produce almost 3 million of cubic meter of CLT by 2023. So why are we not using this material? Why are developers and builders not using this material, having it as a main material? The main reason, one of the main reasons, is the cost of the material. And so timber engineers are able to value engineer the project and to reduce the cost. As in this example, we reduce by more than 50 panels the numbers of CLT panels to install, and we helped the developer to save more than 1 week per floor. The way we work is to strongly implement a digital model in our workflow. Other speakers spoke about the digital twin, but we are already there. The industry is already there and is already using the digital model. In a holistic way, we need to do this. We need to implement the digital model to de-risk the projects and to foresee all the problems we could have on site. Timber is a very flexible material. Let's say we can use it in many different ways, but people are quite skeptical when we speak about this material. So the digital model allows you to receive a 3D model weeks before having the material on site, and you can deeply analyze the model. You can just click on an element and you see who that element is, how big it is, how tall it is, how heavy it is. And once you receive the material on site, you will say, wow, this is what row is what you get. I saw this on my monitor. I received this component on site. It doesn't matter the complexity, no matter how complex it is, because there will be a CNC machine working for you and making that component to assembly on site. So we always try, and we need to value engineer the product to work more off-site and to reduce the time on-site. So on-site, we expect to assemble just a list of components, prefabricated components. All this can be called design for manufacturing and assembly. DFMA is definitely one of my favorite acronyms in the building industry, and I see DFMA as the new value engineering tool. Without this approach, we cannot value engineer any project. Thanks to DFMA, we can see in advance how the robots will work in the factory, and we can see if there are some warnings, if everything is okay, or if something is a bit incorrect, or to solve many problems. In this way, I like to use again these things of the movie Matrix. We see our model, we see our world as an endless sequence of digital numbers. For you, it is a beam, but for us as timber engineers, it's just a sequence, an endless sequence of numbers and letters. DFMA approach or something similar was used even in the 1969 when the first man landed on the moon. They had to foresee every single problem. They had to foresee every possibilities. So they had to work in a very precise way. They didn't have the computer, but they had a brain to use. In this manner, using the DFA, as we are managing many different projects all over the world, just by sharing the digital files with our clients. Of course, when we work in countries like in Australia, we need to take into consideration how the elements will be loaded in the container, how they will be transported. We cannot ask to have a container 5 centimeters longer, 1 inch longer. That is the standard size, and we have to keep it in mind. I'm not saying that we need just to make standard homes. I'm not saying to build to have just black homes, as Henry Ford did more than 100 years ago. He found a way to solve the problem at that time to build for the. I am more saying this case to take inspirations from the. They prefabricate modules, they prefabricate elements, and they assemble those elements on site in the factory. In the factory, in the shipyard. In that way, they reduce a lot the time to assemble it. So this is what they say in China. The best time to plant a tree was 20 years ago. The second best time is now. And I hope we will not plant this tree on Mars. We have a planet and we can save it.